Now let's look at an Excel example of developing confidence interval for a single population variance. Now here is the sample data, and this is about a machine that fills liquid detergents, and the filling process is supposed to will have some variance. So we take a sample of 20 containers, and the sample variance turned out to be 0.0025. However, we cannot expect the variance of a sample of 20 containers to provide the exact value of the population variance, so we want to develop a confidence interval. Okay, so now let's look. So now let's first define the parameters and the definitions, and then we'll develop a confidence interval. Okay, so here are the formulas. We've already gone over those. So the population is the amount of detergent filled per container, and sigma is the standard deviation, or sigma squared. You can make that into squared. Sigma squared would be the population variance, and we take a sample and find the sample standard deviation, and we will develop a confidence interval. So let's define the population. Okay, amount of detergent, variance of the amount of detergent filled, sample size, and the sample variance A squared. Now we need a 95% confidence interval. So here, let's fill out the sample information that's given in the problem. We take a sample of 20 containers, and the 20 containers turned out to have 0.0025 as the sample variance. And now we want a 95% confidence interval. Okay, so alpha is 1 minus the confidence level. Alpha over 2 is that. Now degrees of freedom is n minus 1. So let's go sample size of 20 minus 1. So now we can set up the chi-square table values. Okay, and we'll use the Excel function, which is chi-squared INV. Okay, so like that. For the left side, it'll be probability, which is alpha over 2. So we need to go alpha over 2. So we can actually go B24 over 2, or we can use, so chi-squared INV alpha over 2 and degrees of freedom. That gives us the left side chi-squared value. On the right side chi-squared value, we can use chi-squared INV dot RT. And once again, since this is a confidence interval and the alpha value gets divided into two tails, we have to take alpha over 2 and then the degrees of freedom. That gives us the right side chi-squared value. Now we apply the formula. We apply the chi-squared values in the formula. So right there. So we will have the confidence interval for variance first. Okay, the lower limit is n minus 1, which is the degrees of freedom, times the sample variance, and then divided by the chi-squared value. So we need to use the larger chi-squared value for the lower limit, so which is that one. Okay, and then degrees of freedom n minus 1 times a squared divided by the smaller chi-squared value for the upper limit. So these are the confidence interval limits for variance. We take the square root of the variance, and that will give us the, copy that to the next cell. and that will give us the lower and the upper limits for standard deviation. So these are the limits. Now let's do an interpretation, and you can interpret it for standard deviation or for variance. So we are 95% confidence that the variance or the standard deviation in the filled detergent amounts will be within these limits. So both the interpretation for the variance and the interpretation for the standard deviation. So standard deviation confidence interval is nothing but the square root of the variance limits.